Imagine waking up one morning and having no idea what day it is.
Let me think.
No Monday, no Friday, no January, no December, no birthday written on a calendar, no clock telling you how long until sunset. You simply wake up, look at the sky, and try to understand where you are in time. For us, that sounds almost impossible. But for most of human history, there were no calendars hanging on walls, no printed planners, no digital reminders. And yet, ancient humans still needed to know when things would happen. When would winter arrive? When would animals migrate? When would plants begin growing? When would the rivers rise? When would the days become shorter? And perhaps most importantly, when would food become available again? The strange thing is, humans didn't invent the calendar because they suddenly decided they needed one. They invented it because the natural world kept repeating itself. The sun rose, the sun disappeared, the moon changed shape, the seasons returned, animals migrated, plants grew, and year after year, the same patterns appeared again. At first, humans didn't need names for these patterns. They simply needed to notice them. Imagine a prehistoric stickman standing outside a small shelter. Every morning, the sun appears in roughly the same part of the sky. Every evening, it disappears. One day passes, then another, then another. The simplest calendar in human history was probably the day itself. Light, darkness, light again. The cycle was impossible to ignore. But the sun offered something else. Its position in the sky changed throughout the day. When it was low, morning was beginning. When it reached its highest point, the middle of the day was approaching. When it began dropping, evening was coming. Humans could use shadows to estimate where they were within the day. No numbers were necessary. No clock was required. The sun itself was the clock. But one day was not enough. Humans needed to understand longer periods, and for that, they had the moon. Look at the moon for several nights, and something strange happens. It changes. A thin crescent appears. Then it grows. It becomes a half moon, then a bright full moon. Then it slowly disappears again, and eventually, the cycle begins again. This gave ancient humans another natural unit of time, the lunar month. One cycle of the moon became a useful way to measure a longer period than a single day. But there was a problem. The moon doesn't perfectly match the seasons, and the seasons were extremely important. Imagine you were living thousands of years ago. Your group depends on plants. You know that certain plants appear after the cold season. You know that animals migrate at particular times. You know that winter eventually returns. But if you want to prepare, you need to know when. The seasons created a much bigger clock. Spring, summer, autumn, winter, over and over again. The challenge was figuring out exactly how long the entire cycle lasted, and humans became remarkably good at watching it. They watched when certain stars appeared. They watched where the sun rose. They watched when plants flowered. They watched when animals arrived. They watched when the weather changed. And they remembered. Generation after generation, people passed this knowledge to their children. A hunter might know that a particular animal usually appeared after the first signs of spring. A gatherer might know that certain berries appeared shortly after a particular period of warming. A farmer could learn that planting too early meant losing an entire harvest. Suddenly, time was no longer just something that happened. It became something humans could predict. And prediction changed everything. Because knowing that winter is coming is useful. Knowing approximately when winter will come is much more useful. This is where calendars begin to become more complicated. Ancient humans started creating physical ways to track repeating patterns. They marked bones. They carved lines into objects. They used stones. They watched the horizon. They observed the moon. Some ancient objects contain repeated markings that may have been used to track cycles of time. But we have to be careful. Not every ancient mark was necessarily a calendar. A collection of lines could represent many things: counting, records, rituals, or simply decoration. We cannot always know exactly what ancient people intended. But eventually, there is much stronger evidence. Ancient civilizations began deliberately organizing time. And one of the most important developments happened when humans began farming. Because farming created a completely new relationship with time. A hunter can move when food becomes scarce. A farmer cannot simply walk away from a field. The crops have to be planted, they have to grow, and they have to be harvested at the right time. Plant too early, and the cold could destroy the crop. Plant too late, and there may not be enough time for it to mature. Harvest too early, and valuable food is wasted. Harvest too late, and weather could destroy everything. For farmers, the calendar became a survival tool. It wasn't just about knowing what day it was about knowing what to do next. And as agriculture spread, the importance of accurate calendars grew. Ancient people began watching the sky with extraordinary attention. They noticed that the sun did not rise in exactly the same place every day. Across the year, its position shifted. The length of daylight changed. Eventually, it reached certain points and began moving back in the opposite direction. These became the basis for some of humanity's most important astronomical observations: the solstices, the equinoxes. At the summer solstice, the northern hemisphere experiences its longest day. At the winter solstice, it experiences its shortest. Around the equinoxes, day and night are approximately equal in length. Ancient humans didn't need modern physics to notice these patterns. They simply needed to watch. And some did, very carefully. Across the ancient world, people built structures that helped them track the movement of the sun. Stones, pillars, temples, openings aligned with the horizon. These structures could help mark important points in the yearly cycle. The sky became a giant calendar, and humans began turning that calendar into culture. Different civilizations developed different systems. Some calendars were based mainly on the moon. Others focused more heavily on the sun. Some tried to combine both, and this created a problem. A lunar month is roughly 29 and a half days. 12 lunar months give you a little under 354 days. But a solar year is roughly 365 days. That difference seems small, about 11 days, but it adds up. After 1 year, you're about 11 days out of alignment. After 3 years, you're more than a month out. Eventually, a calendar based only on lunar cycles would drift through the seasons. A month that once corresponded to spring could eventually appear during winter. That was a serious problem for agricultural societies, so ancient calendar makers had to solve a mathematical puzzle. How do you make the moon and the sun fit into the same system? Different civilizations found different solutions. Some added extra days. Some added an entire extra month from time to time. Others created complex rules to keep their calendars aligned with the seasons. This is one reason ancient calendars could become surprisingly complicated. And there was another problem. A year isn't exactly 365 days. It's a little longer. That tiny difference matters. If you pretend every year is exactly 365 days, your calendar slowly drifts. At first, nobody notices. After a few years, the difference is still small. But after decades, it becomes obvious. After centuries, it becomes enormous. So humans eventually needed another correction, the leap year. The basic idea is simple. Every so often, add an extra day. That tiny adjustment helps keep the calendar aligned with Earth's journey around the sun. It sounds obvious today, but discovering the need for such corrections required generations of observation. Humans had to notice that the calendar was slowly drifting, and then figure out why. The calendar became a combination of observation, memory, mathematics, and prediction. But calendars weren't only useful for agriculture, they became incredibly important for civilization itself. Imagine a growing ancient city. Thousands of people live there. There are rulers, farmers, merchants, soldiers, religious leaders, workers. Everyone needs to coordinate. When should taxes be collected? When should markets happen? When should festivals begin? When should armies move? When should religious ceremonies take place? A shared calendar makes coordination possible. Time becomes a system that an entire society can agree on. And that is a huge change. Because before calendars, time was mostly something you experienced. After calendars, time became something society could organize. Ancient rulers understood this. Controlling the calendar could mean controlling important events. If a king declared that a particular day was a festival, everyone knew when to gather. If religious leaders announced a sacred date, the entire community could prepare. The calendar connected individuals to something much larger than themselves. And eventually, humans started giving names to periods of time. Days became associated with cycles. Months received names. Seasons became organized. Years could be counted. And history itself became easier to record. A ruler could say that something happened during a particular year. A farmer could remember when a major flood occurred. A civilization could record when a war began. Time became part of written history. But there is something fascinating about all of this. The calendar feels artificial, yet almost everything inside it comes from nature. The day comes from Earth's rotation. The year comes from Earth's orbit around the sun. The month originally comes from the cycle of the moon. Humans didn't create these cycles. We discovered them. Then, we turned them into a system. And that distinction matters. A calendar isn't time itself. It's a human map of time. Different civilizations created different maps. That's why calendars have never been completely universal. Some cultures began their year in different seasons. Some used different numbers of months. Some followed the moon. Some followed the sun. Some used both. Even today, different calendar systems still exist around the world. Our modern calendar feels natural because we use it constantly. January, February, March, April, it seems obvious. But none of those names are written into the universe. They are human decisions. The universe doesn't know that today is Tuesday. Earth doesn't know that it is August. The moon doesn't know when a month has officially ended. Those are systems humans created to describe repeating natural events. And perhaps that's the most fascinating part of the calendar. It represents one of humanity's greatest abilities. We see patterns, and we turn them into knowledge. We see the sun rising every morning and create the day. We watch the moon changing and create the month. We watch the seasons returning and create the year. Then we take those cycles and build civilizations around them. Ancient humans didn't invent time. They invented a way to keep track of it. They turned the movements of the sky into something they could remember, something they could predict, and eventually something they could share. Today, you can look at your phone and instantly know the date. You can schedule something 6 months from now. You can plan a vacation next year. You can set an alarm for tomorrow morning. It feels effortless. But behind that tiny number on your screen is thousands of years of observation. Thousands of years of people looking upward, watching the sun, watching the moon, watching the stars, waiting for the seasons, and asking one incredibly human question: what happens next? Because the first calendar wasn't really a piece of paper, it was the sky. And long before humans wrote dates, they learned to read it.